Hello and welcome to Aviation Map Reading by Conway Bound of Independent Productions and Aviation Services. This is part 1 in a series of videos on aviation map reading, and in this presentation we're going to be looking at the aim, method and end state of what we're trying to achieve and some definitions. Well, being able to navigate from the air is vital for emergency services and primary industry and allied occupations. And this module will provide basic knowledge to assist in making the job easier, safer and more efficient. Easier means less stress for you in the cockpit, safer means you'll get home to mum and the kids at the end of the day, and more efficient means saving money and saving time. Aim, method and end state. Well, the aim is to create the awareness, give the knowledge and the skill in the art of navigating from aircraft. And the way we're going to do that is through an audio-visual presentation uploaded to YouTube. Also facilitator-led instruction where required, and for those of you involved in a standardized course, we will be conducting an exercise in a helicopter. And finally, the end state what you're trying to achieve is a greater understanding of aerial navigation, which will allow that greater efficiency and safety I spoke of earlier. The various things we'll be looking at: definitions and the various types of maps, that'll be the first part. Scales, projections and data, and then on to coordinate systems such as latitude and longitude, universal transverse Mercator and the military grid referencing system. Map legend and marginalia being all the items in the margin of the map. The concept of north, map interpretation and navigation. Look at satellite navigation using the GPS system and various apps you can acquire for your iOS or your Android smart devices. And aerial navigation, deductive reasoning and preparing your map for navigation. References. The Air Observer's Learner's Manual from the New South Wales Rural Fire Service, the Aviation Basic Knowledge Training Manual, again from the New South Wales Rural Fire Service, navigation for the private pilot licence, there's lots of different sources for that, various internet sources, and my own acquired knowledge and skill of 23 years of military and civvy flying. Some definitions. Well, first of all, what is a map? A map is a 2D representation of a 3D surface. When you think about it, a map is a piece of paper. It has width and it has length, but it doesn't have depth or height. The Earth's surface is a curved surface, so there's the first problem, trying to represent a curved surface onto a flat surface, and it has that third dimension of height or depth. So therefore you could say that it's a generalized representation, and the more detailed documents, the more detailed maps will have such things as contour lines and other important data. A chart is a type of map. A chart is usually used for navigation, so you can have an aeronautical chart or a navigational chart versus say a topographical map or a topo map. Here is a typical topo map. This is the area just to the north of Wagga and shows a lot of great information. Let's have a look at some of it. Along here on the left hand side you can see a number of curly brown lines. Well, those brown lines are contour lines. The closer they are together means the steeper the terrain is. As you can see here in the middle there, the contour lines are far apart, indicating that the ground here is more undulating and much more flat than it is say over here. Down to the south we have this blue line here, the Murrumbidgee River, represented by this blue feature on the map. So those are some natural features. Then we can have some cultural or man-made features. For example, roads, like Coolamon Road here, and Olympic Way, both of which are leading into Wagga Township. So there's North Wagga and Wagga City itself, represented by that mauvey colour. And things like golf courses and these little black dots are buildings, etc. So there's lots of great information on this map. And very useful for the person who requires information about the terrain. I'll also point out a couple of other things. Notice how the roads up to the north here are shown in red, whereas down here they're shown in black. That's because there's two different editions of this map, probably done by two different agencies and then joined together. Now let's have a look at what it looks like when we compare this with aerial photographs of exactly the same area. So here are some of the features I pointed out on that last slide. There's that high ground. Notice how it's darker than the rest of the area. Well, high ground doesn't normally get cultivated like this land here, so a lot of the vegetation stays on the high ground. And so you can see that there is darker because the darker vegetation. There's the Murrumbidgee River. There's Wagga Township, and there are those two roads that I pointed out before, Coolman and Olympic Way. So the challenge for the person navigating from the air is to visualize what is on the map and compare it to what they see. Another thing with this aerial photograph, notice how the color of the fields there is different up to the north than it is to the center and the south. Well, that's because this is a photo mosaic, so a number of different photographs have been stitched together, and so sometimes your Google Earth photos and other such photos may not necessarily be completely representative of what you see. Some key maps and charts that we're concerned with. Well, topographical maps, or topo maps, show topographical information as one of the most important components of the maps, and it uses various things such as contour lines, hatching, which is cross-hatching and shading, and tinting, which is use of colours. The most common scales for topo maps are as shown there, 1 to 250 thou, 1 to 100 thou, etc., with 1 to 100 thou being one of the most common. Here is an example of a topographical map. This is a 1 to 100,000 scale map. Some features to note. These lines here are called grid lines, so it's a grid pattern overlaid over the representation of the terrain. The lines running north-south are called eastings, and the reason for that is, look at these numbers up the top here that annotate each of these lines. They get larger as you go from west to east, so it's measuring the distance from west to east. The same applies down the side here, where these east-west lines are called northings, because the numbers get larger as you go to the north, because they are measuring the distance from the south to the north. Looking at the map itself, let's have a look at some of the information. Well, the green represents green vegetation. You have dark green along here, and then light green, indicating the vegetation is not as thick in the light green areas as it is compared to the darker green areas. And then you have areas like this which have virtually no shading, and that indicates that the vegetation there is quite sparse, may only be grassland. We have your typical contour lines, and by convention they're usually brown. Cultural features or man-made features, things like these tracks, the ranger's hut here, and other information of use, which we'll describe later on. This is a map used to denote, or used for aerial navigation as well as some land use. Instead of using the grid pattern of the 1 to 100,000 scale, this uses tick marks along these lines of parallels of latitude and meridians of longitude, and that'll be discussed in the next video on the coordinate system. There is something of interest though that I would like to point out with this picture, where these lines here represent latitude and longitude. These blue lines, you can see here there's 7, 8, 9. They are actually those grid lines from the topo map. These represent 10-kilometer squares, and you can imagine that this is the grid system of the UTM map, or the topo map, overlaid onto this map, which uses predominantly the latitude and longitude scales for plotting coordinates. But we'll talk more about that later in the second video. Information on this particular map of interest to, say, the pilot. Well, here is an airfield up there. That's of interest to a pilot. These straight lines here in blue or blue purple, those are power lines, and from the air they're very easy to see, so it's great for navigation. But also it's interesting for a pilot who may have to do some low flying, such as doing survey or support to the emergency services. So knowing where the power lines are is particularly useful, so you don't fly into them. Other information, well, the cultural information, Griffin Way and the Hume Highway, they're marked there with the township of Yass. An abandoned railway, that's all information that is useful whilst you're flying, because that might be the items that you're going to be visually navigating off. Dark green areas indicating foliage. There's a nature reserve here. It's got the boundary of the nature reserve. And then down to the southwest here we have the blue feature of Lake Burrinjuck. This map here is a topographical map, and you can see the squiggly lines of the contours. Has great information there if you're using this on the ground. Has cultural features as well, the roadways, power lines coming down here to the various little huts and houses down here around Good Hope. It's a caravan park, so it's got a lot of great information there for people who are using it on the ground. Some key maps and charts that we're concerned with, well, aeronautical charts. The three most common aeronautical charts you'll find within the civilian flying industry are the WAC, the VNC, and the VTC. The WAC stands for World Aeronautical Chart, is a 1 to 1 million scale chart, which means that the features on there are quite small in that the area covered by the map is large, so therefore the items on the chart are much more abbreviated. And because this is a chart, it's mainly concerned with navigating. So I'll show you a picture of that on the next slide, and you can see the information that's presented. The next chart there is the VNC, the Visual Navigation Chart. That's a 1 to 500,000 scale map, which means it's got a lot more information on it. And it's designed again for navigation, but it also contains information on airspace and information on communication requirements. The last one is the VTC, the Visual Terminal Chart, which is a 1 to 250,000 scale, and has even more information than the previous two charts. The ONC, the TPC, and the JOG are three different types of military aviation charts or aeronautical charts. Same scales as the WAC, the VNC, and the VTC, but the information is presented somewhat differently. The ONC, the Operational Navigational Chart, has limited detail and is designed for medium level flight, so you're at altitude, say 15, 20,000 feet. The TPC is a Tactical Pilotage Chart, and that's the same as the ONC, but it's got a larger scale and it's got more detail for aircraft that are flying at lower level. And then we have the Joint Operational Graphic, the JOG. It's got 50 or 100 meter intervals for the contour lines. It's got a lot more information for the military pilot. So here is a picture of a WAC, a World Aeronautical Chart, 1 to 1 million scale. Some interesting information on here for the pilot. Well, first of all, these round circles, I suppose all circles are round, aren't they? These circles here depict airfields, Gingin, RAF Base Pearce, Perth International Airport, Jandakot, Garden Island Navy Airfield, and Rottnest Island. So if I'm flying around the Perth area and I have mechanical difficulties with my aircraft, I'm going to know where the closest airfield is that I can land, make an emergency landing. More information that's useful for a pilot, well, these things here that shows towers, 409 feet above sea level is the top of the tower, and 263 feet is the actual height of the tower from the top to ground level. These squiggly lines here are power lines, again great for navigation. Other information it provides gives navigation information such as this NDB, this non-directional beacon here at Caversham, right there, or this one here at Parkerville. Doesn't show the frequencies, you would need to look those up, but the next two maps next two charts have that information, and I'll show you those next. Other information for navigation, this thing here is a light. It says flashing white light 6-second interval. So if I'm flying along the coastline and I see a white light up ahead and I'm flying in bad weather, I get an idea that it's a Beam Little Island. Same deal over here for Rottnest Island, flashing white light 7.5 seconds, so I can count the interval and I know that that light over in the distance there is probably Rottnest Island. As far as vertical relief is concerned, the depiction of vertical relief is done by the shading. See the shading here, little bits of shading there and here. Also the tinting, you can see that it uses different colours here to denote higher ground. So this bluey green colour shows low-lying ground around sea level, and then you come up to this buff colour and a contour line surrounding it, indicating that the terrain is rising there. So for a pilot flying from west to east knows they're going to be approaching some higher ground. This here is a 1 to 500,000 scale map, the Visual Navigational Chart, and as I said in the previous slide, it provides a lot more information. Red lines indicate special use airspace. In this case here they are restricted airspace, denoted by the R, that's Romeo 583 Bravo. It's effective from surface up to 10,000 feet. So in order for me to fly in this area here, I have to make sure that it's either not active or that I have the clearance to enter it from whoever is controlling that airspace. And in this case here, it's the Department of Defense. This is all airspace used for fighter training. Flying down from the north down towards Taree, I know that when I enter this green dashed line here, I need to be listening out on this frequency here, this Common Traffic Advisory Frequency, or CTAF, and that's 118.1. So all aircraft operating within that green line should be on that frequency. Other information that's of use to the pilot, well, that circle there, they indicate airstrips. Again, if I have problems, I can locate if I can locate the airfield, I might be able to put down there without having to do an emergency landing in a field somewhere. Power lines, squiggly lines, again, that's a similar sort of feature that you can find on the WAC. Mine, easy to see from the air. Towers on this high ground here. Also, these are the lines here, these symbols here. H stands for hang gliders. There's hang gliders around here and hang gliders here. Over here it's model aeroplanes. So you might find yourself going head to head with a model aeroplane at about 300 feet. For depictions of vertical relief, see the low ground has this sort of greyish colour, and then as soon as we get to the higher ground, we see the buff colour and a contour line around that, and then the higher ground is that darker, it's almost like a sort of a salmon colour. So lots of good information there on this 1 to 250,000 scale chart. You'll notice that this line here and this line here have got tick marks on them, and they're the latitude and longitude lines, and degrees and minutes are used for navigating. Here is a visual terminal chart, a VTC. It's called a terminal chart because you are arriving at the terminal phase of your flight, and the intention is that you would be using this chart to navigate into land. Like the VNC, same conventions. Red lines mean special use airspace, green lines mean something to do with communication. You can see that here, there's the green line, and there are some red lines. Terrain is depicted the same way as on the VNC, but in this case here they use white instead of that sort of greyish colour. And then as you start to reach areas of higher ground, you'll see a contour line, usually surrounding some tinting. Other information on this chart: golf courses. There's one there. There's another one. There's another one. There's another one, and another one. The reason why they've got golf courses there, it's not because pilots like to play golf, it's because golf courses are easy to see from the air, so therefore it makes them easier for navigation. But also, golf courses have long fairways, long areas where there is nothing there, which means that if you have to do an emergency landing, a golf course is a great option to turn for, and then if you have to put the aircraft down, it's unlikely you're going to hit anything of significance, maybe a golfer. Other symbols of use, things like quarries and mines. Here we've got some model aeroplanes as well. It also provides navigational information such as these reporting points. That triangle there is a reporting point. It's also got its latitude and longitude that I can plug into my GPS. So if I'm flying down this dotted line, which is what's called the lane of entry, it's a conventional track for light aircraft to transit through special use airspace. I'll approach this reporting point and I'll contact air traffic control at Williamtown and say I'm at Broughton Island and I would like to track the lane of entry southbound, and they might give me clearance down through here, maybe tell me to hold at Anna Bay, so I might have to do a racetrack pattern and hold at Anna Bay before I can continue on down to, say, Nobby's Head down past Newcastle. So there's great information on this chart as well, and it pays just to sit down for a few minutes before you go flying and have a look at it to get a bit of situational awareness of where things are. Now when we start talking about charts, we've only talked about aeronautical charts, but navigational charts for use on the water are useful to have a look at. It doesn't have the same sort of information you'll find as on an aeronautical chart. It doesn't have too much information about the land, but it does have a lot of information about the water. Things like soundings, 22 feet, 23 feet. You know that if your draft of your boat is less than 20 feet, then you should be okay around this area here. But if it is 20 feet, well, then you're not going to do too well sort of around this area here. The land doesn't actually show too much information. You can see there's a naval hospital here, cemetery over here, but not really too much more about the developed or the undeveloped land. Over here, this cliff face is depicted by these dashed lines, so it doesn't even use the same conventions as topo maps or aeronautical charts. It does show other sort of information, like this footbridge here has horizontal clearance of 40 feet and vertical clearance of 15 feet. So my boat, if it's got a mast of 20 feet, it's not going to make it underneath that bridge. So good information there, and it's very useful for those who are navigating on the water. Not so much useful for anyone else. This is what's called a cadastral chart, a cadastral map. It has a lot of information that's useful for, say, surveying or other town planning activities. A cadastral map means that it shows usually boundaries of something, property boundaries or boundaries of areas on the ground. Here we see, along here we see the right-of-way for the roads and a cul-de-sac and another road there, and all the blocks that are being planned to be released for sale. You can see the contour lines there, and as I said before, contour lines that are close together means the terrain is steep. But in this case here, I would expect that not to be such steep terrain, especially if they are residential blocks. So I would suggest that the contour lines here are representative of close contour intervals, maybe 10 centimeter intervals or 50 centimeter intervals. So in this case here, this block has got 1, 2, 3, 4, 5, 6, 7, 8 contour lines from one end of the boundary to the other end of the boundary. So that could mean a fall of 8 meters, or if they're 50 centimeter contour lines, it's a 4 meter drop. So I'm not quite sure what the scale would be there. I would suggest it's probably a 4 meter drop or something similar. Here is a topo map that I showed you before. It does have all the topographical information, but it also has cadastral information too. See the property boundaries, and it's got even lot numbers. So good information there. That's the end of part 1. I hope you enjoyed that, and part 2, 3, 4, and 5 will follow. Anyway, I'll see you soon. Have a good day.